And hello, team. Welcome back. We have a pretty exciting lesson, cybersecurity in information systems. It's a whole career field within itself. So we will be going through these objectives throughout the next hour or so. So you're welcome to pause on these and take a look around. Frankly, we're just going to cover them at speed. There's more information in the book. I added plenty of great links online. Please refer to them. And I actually posted them this week in the order that I think they would be useful for you. Okay, so why learn about the hardware and the software? Well, I want to emphasize to you as information security manager, information system managers, right? Then no matter what career field you're in, even if you're not in cybersecurity portion of information systems, that you are expected to have the educational background to define the business needs for the hardware and the software that you are utilizing. So that really is the crux of the matter. Some of the things that you'll be looking for include the CPU, or sometimes we just call it the processor, how much memory, how many buses, and input and output devices. Just real quick, as a review for most of you, the CPU, of course, is going to start and fetch instructions from that get put into RAM from the BIOS. So the BIOS is going to start booting up your system, and the CPU is going to fetch those instructions that are put into that electronic memory from BIOS. And that electronic memory was stored in ROM, right? So we have this memory that we need for startup instructions. The BIOS is going to take that and from ROM put it into RAM so it's active, and then the CPU can engage it, right? It says memory. Notice it says main memory. There are lots of forms of memory. We will talk in terms of RAM, random access memory. That's real fast instructions that are live so that the computer can act on it quickly. There's ROM, read-only memory for boot up, for example, etc. And so the BIOS is going to start the monitor, it's going to start the keyboard, and oh, excuse me, it's going to do some basic checks to make sure the computer is working properly. And in this, as the BIOS runs the boot sequence along the way. And then later you'll click on a program you want to use, like Microsoft Word. And when the program loads, it's moved from storage, say in your hard drive, to memory, where it can be used very quickly. And once the app is in the main memory, the computer can carry out the instructions or execute the program using the CPU and the input-output devices. So the main memory is a component of the computer that is going to give the CPU those working instructions and data that it needs to operate. You'll use other data. You'll input other data from your input and output devices. The chief function of memory is really just to rapidly provide data instructions to the CPU. That is the main component of the computer. It's doing most of the heavy lifting. There are integrated circuits imprinted on silicon chips that are making all this happen behind the scenes. And I added a link to circuits as well. You might want to check that out. The memory is stored on the chips using on-off states, or we often refer to them as ones and zeros, by the millions, right? And your CPU is tracking all of that. There are, when it comes to terms of ones and zeros, we use in general, right, for IP version 4, we use 8 bits to represent a character, and 8 bits together form a single byte, right, BYTE, or capital B is its abbreviation. And so a byte is 8 bits that together represent one single character, and your CPU is managing millions of those. And So storage capacity on your computer is usually measured in terms of bytes. 1 byte being equivalent, as I said, to 1 character of data. Now, when you open an application, as I mentioned, it runs inside an operating system until you close it. So most of the time, you'll have more than one application going at a time. That's known as multitasking. You might have a Word document up. You might be listening to music at the same time, right? And in the middle of all that is the CPU. The CPU, as I mentioned, is the brain of the computer. It contains all the circuitry needed to process the input, to store data in memory, temporary storage, to have output results. So the CPU is constantly following the instructions of the computer programs that tell it which data to process and how to process it. Without the CPU, we could not run a program on a computer. Now, the CPU is often measured in terms of clock speed, and we do that in terms today of gigahertz, right? That's a excuse me. A gigahertz is generally a cycle, right? Technically, it's a pulse. Right? We're talking electronic pulses. It's a pulse synchronized by an internal oscillator. But for our purposes, a gigahertz is a basic unit that helps us understand CPU speed, right? And you interact with your program using a GUI, a graphical user interface, as one of the input-output connections. And so your computer is just an electronic device. Operate under the control of the instructions that are in memory, and the information and data is now endowed with meaning. That is the definition of information. Information is data endowed with meaning, and now we've created that. So this requires input, processing, and output. The input devices can be things like hardware, such as keyboards and pointing devices. Might be a stylus on your iPhone or a tablet. Some laptops have touch screens, which are nice. And output devices can be like printers, 3D printers, which can print solid objects made of plastic substances, etc., etc. So that's a little bit about the information here. Just a couple of notes on gigahertz before I end this. And I know I've spent a lot of time here, but this is foreign to some. There's a lot here, and I've provided some other links on the Moodle site to the motherboard, so you can see where the CPU sits and the memory sits and other things on your motherboard, just for fun, right? Realize that a hertz means times per second, and giga is a prefix that means a billion. And so a gigahertz is a billion times per second these operations are going to be happening. So and it's in reference to clock cycles. So 2.5 gigahertz processor is going to complete a cycle, a clock cycle of 2.5 billion times per second. Wow, fast. I love it. Okay, here's another slide I pulled from a different presentation that kind of summarizes the same. You could pause the slide, take a look at it. You have input, output, and processing device notes. I just thought it was interesting. I hope it's useful to you as well. Okay, so I think at length I've already covered the anatomy of a computer, the phases for completing instructions and the execution phase. And also in the anatomy of a computer, this transition between memory and cycle times. Again, I have some great links online. Please refer to those for more information. They're really super presentations. I think you're going to like. The first one is by an Amazon team. Really exciting. Okay, so I think we've already covered most of this slide. There are processors, a CPU, and then there's a multi-core processor where you have several. Clock speed and gigahertz we have also already addressed. So integrated circuits. I did post a great link on the Moodle site, week 4 for integrated circuits. It's a tutorial, you read through it. It's very, very interesting. I think you'd enjoy it. But basically, the integrated circuit is just a set of electronic circuits on one small piece of a semiconductor material, normally silicon. So hence the name Silicon Valley in California, right? And so read through that tutorial. I think you'll get a lot out of it. It's really beyond this course. This is not computer science. This is information systems. And so this gives you the ability to do some multiprocessing and, of course, parallel processing, where you can simultaneously execute the same task on multiple processors along the way. It's pretty exciting, actually. And then we turn in parallel processing to grid computing. So grid computing is really uses a collection of computers. Can be owned by multiple individuals or organizations, so different business units within your organization, and that are coordinated in a manner to solve a common problem. So you combine these computers to create a grid to solve a common problem. And it's a low-cost approach to parallel processing. That was the point that I wanted to make there. Now, with main memory, I did want to share that, again, just as a review, it's a component of the computer that provides the CPU with that working storage area for programs instructions. So the application, when you click on it, is pulled into the main memory, and the CPU will reference that for instructions and data. The chief function, as I've already mentioned, I believe, is to rapidly provide data to the CPU, etc. And I've already mentioned that 8 bits are used to represent a character, and the 8 bits together form a byte, right? A byte. And so 1 byte being equivalent to 1 character of data along the way. So this is so the byte is abbreviated B, and the number of bytes 1 is a character. Kilobytes, megabytes, right? We talk in terms often of gigabytes nowadays, but terabytes are becoming common in the personal home computer slowly. At work, where I'm at, petabytes are very common. It gets astronomical, but some of the abbreviations that you will be aware of. And in your lifetime, you will be working in this realm: exabytes, zettabytes, and yottabytes. I have no doubt. So pay attention in terms of the big data conversation. I mentioned lots of forms of memory. RAM is one of them, random access memory. And that instructions or data are placed here temporarily, and they're read very quickly from this read access memory. So it's a form of memory with instructions or data that is temporarily stored. If I turn off my computer, everything in RAM is gone. It's wiped out. It was not saved to my hard drive. RAM chips are, and so we call that volatile storage. It's a volatile storage device, meaning that it will lose its contents if it's turned off or disrupted. There are lots of forms of RAM, as you see there. Static random access, dynamic, double data rate synchronous, etc., etc. It's very interesting, and that's for further study if you choose to go in that direction. Now, I did want to mention something about cache. Cache memory is a type of high-speed memory that a processor can access more rapidly than the main memory chip. And this is used to help ease a bottleneck along the way. So I like to mention cache. People, from a security perspective, do get concerned. I will also mention that there are 3 levels of cache. One is level 1 of the CPU chip. Level 2 cache memory can be accessed by the CPU, and level 3 as well. Anyhow, just interesting. Okay, let's take a quick break. RAM and cache, and we will come back shortly.